Okay, welcome to the second Unity workshop. I am surprised that there aren't more people here, but at least y'all are here, so y'all be knowing more than the other people that didn't come. So, what we'll be learning today is about movement and input, basically, and rotation and frame rate independence. And we'll also go over something called vectors. So first, you need to have the template project that you should have cloned or downloaded from the GitHub. How many of you haven't done that yet? Okay. So first, we need to actually open it. So if you have Unity Hub, you just go to Add. Wait, no, not Add. I meant Locate. Wait, no, this is not the right projects. And then Add. Yeah. That makes more sense. And then you go to where you cloned it.
Give it the high-level folder.
Yes, and then you select the folder. And if you have a different version, you should select the version that you want to open it with. Preferably this version or later, which is, there's only one version after this, because... Yes.
Should I just
Yeah. Which version do you have?
I was trying to use, yeah. That's 1.12.
1.12. Oh yeah, that's definitely an older version.
So this is the free version.
So if you have a credit card, you can just I'm used to this layout. So it's from adding and finding everything.
Like where
You
you
do not download the Magic Disk? Okay, so it's really you have a link to it?
Anyway, once you've added it, you can just click on it to open, and we'll wait for that to happen. Anyone else need help?
That should be a thing.
How far are you?
That's gonna take a long time.
Yeah. I'll just follow along with this. I'll probably just write the code.
Wherever you expect it. It's getting there.
I mean, after it fills up, we'll send you an install. Like, I just installed this version on this computer because it wasn't installed.
How long does that take?
Like 15 minutes.
Oh. Wait, I have an SSD on this.
So now that's somewhat, you know, get an SSD. sort of all right, I'll just follow
Folder.
and desktop. Just
Shouldn't be that bad.
The only reason why you would need like the template project is because it provides a sprite
Yeah.
and a script that just has a bunch of constants put in so that you don't have to type in entire strings. Well, I didn't think it would take this long. Maybe I should like open it ahead of time.
Maybe this is one computer's cursed.
Oh my god. Okay, when I was like trying to open it on my computer with like a different version, so I had to re-import stuff, it was faster than this. So I thought, hey, why not update it so it'd be faster? Okay. So once you've opened it, you should open the scenes folder and choose the sample scene, because for some reason it makes an untitled scene. So, is everyone ready? Except for like, okay. So, if you click on this, you'll notice that one of the components is called transform. This controls like what position and rotation that the object is, and also the scale. So you can just change it like this, or by just typing in a number.
Today's a lot about movement, so
Yeah.
it's all in end result going to be changing the transform. Some
Yeah.
of it's more direct than others. There's different ways to do it. We'll go with that. But that's how positions store in Unity.
And also, we'll be showing you how to do this within a script instead of just changing it in the inspector. Because what use of it if you just change it here and have it stay like that? So, yeah, like I showed you, there's 3 different parts of the transform. There's the position, the rotation, and the scale. With rotation, it's the XYZ is like which axis it's rotating around. So in 2D, you would generally use the Z rotation because the Z axis is the one that's going towards and away from you. And scale is just how big it is. For position and scale, if you're in 2D, you generally aren't using Z because for scale, the objects, 2D objects are like flat, so it doesn't really affect it. And for position, it does have use if you're like, if the objects are like in front of each, if you have multiple objects and one is in front of another one, but it doesn't really like make it closer since it's not, what's the other camera mode called? Yeah, orthographic. So I showed you where you can manually change the transform in the inspector. So, yeah. Now, let's get to scripting. So this is the main function that you use to move objects, transform.translate, which just basically means move it change the position by that amount. And Unity's coordinate system is positive x to the right and positive y up and positive z forward. So whatever numbers you put in there, it will move it to the right, up, and forward. Or if you put a negative number, it'll go the opposite direction.
Is it like Python, it's case sensitive?
Yeah. And there's also one for rotating. Same thing. With each parameter, it rotates around a certain axis. So if you're in 2D, you generally only use the Z. There are some cases you might want to use X or Y, but usually you don't. There's also transform with a capital T. That one refers to the class transform, which is if you're trying to get the component like that. But there's not really a reason to use get component transform because every single game object and components as well come with a transform variable that is basically this. So instead of just doing like get component transform dot whatever or storing it into a transform variable, you would just use transform lowercase.
Getting a transform is probably the most common example of getting a component, so much so that there's just a shorthand for it on all game objects.
Yeah.
So you don't, even though transform is a component, and you can do this and it'll work, you don't have to. It's just dot transform and it's already there for you on any game object.
Yeah, every object has to have a transform, so that's why Unity just put it in everything. So now you can try moving an object. So inside the Unity sprite object, there should be a script that's already been added to it called Unity Sprite Script. If you go to the asset folder, there should be the Unity Sprite script there, so you can open it and play with it. Remember that whatever you put in start happens once and in the beginning, while whatever you put in update will happen every single frame. So for now, just do that. And you can play with transform.rotate if you want. So, does anyone know what the answer to this is? What would be the line of code that would move an object 1 unit up and 1 unit right?
1, 1, 0.
No, the full code.
Transform that would
Put it
translate.
in the update section and put 110 for transform.translate 110.
Yes. So the correct answer is, oh, I didn't Okay. Oh, there it is. Yeah. Also, if you notice, it takes float as a parameter, which means you can use decimal values. You don't have to use integers. Especially since if you look in Unity, every single one of these sections is one whole unit. So if you're moving 1 unit per frame, it's gonna move really fast.
60 frames, I could remove 60 of those squares somewhere, it was off screen.
Transform.translate 1.
Can you go right? I can see the top.
Top.
Is that all commented out?
Because like, wait,
The stuff that was there already.
Okay, so the script provides these 3 variables. This is for later when we're doing input, but it's just there so you don't have to like. I mean, the variable names are longer than the actual strings, but it's there so that like you won't misspell it.
I think it's a good habit to have too, because whenever you're working on a project, you might change the actual inputs name. So if you have them in one value, you don't have to change them on 20 places in your whole code. You only change that one value and you change it correctly.
Hello, are you here for the Unity workshop? Are you here for the Unity workshop?
Conversation.
Guess not. So if you press the play button, it'll just zoom off to this corner. And it's probably still going. Okay.
You put a stop on there? And
Huh?
just have it come back the other way, like at a certain variable, just stop. Like when, like, both, let's say both are like 255, 255, 0.
You can do
You always
that.
have a simple statement where if it's beyond a certain range, you start subtracting instead. That would be
So now let's get to input. Unity has an input manager where you can just set up certain input methods like buttons and also the mouse and controllers. But to access that, you go to edit and then project settings, and then you click the input tab on the left. In older versions of Unity, project settings actually also opened a drop down menu that you can like choose one of these and it'll just automatically open it for you. So let's look at that right now. Go to edit, project settings, and then input. Any questions so far? Okay. So when you open it, you'll see there are 18 different inputs that Unity provides for you. Or, well, some of them are identical, but they're for like controllers. So like this one is called horizontal, which is basically left and right, A and D, and vertical, up and down, and W and S. There's also this one, horizontal and vertical. This one's for joystick, up and down, left and right. There's also 3 fire buttons, which is, this is for mouse click and left control. a second fire button, which is left alt and mouse right click, and a fire 3 button, which is left shift and I don't know what this is, the scroll wheel maybe. There's also a jump, which is space, and then there's mouse X and mouse Y, which tracks your mouse cursor position. And there's mouse scroll wheel, which tracks the scroll wheel. And then there's the same ones, but these are for controller input. And then there's submit, which is the enter key, and space, and the cancel button. So those are, if you notice, these have names. They're very important because that's how you're going to access them. Horizontal, vertical, fire 1, and so on. Any questions? Okay. Oh yeah, you can also add new buttons by changing this number. It's really weird, but that's just how you do it. You change the 18 to a 19 and another one should pop up, and that's when you like change each of the settings. So in the code, this is how you would access or get the state of the buttons. There's input.get button down and a string. For the string, you put in whatever the name of that input is. So for jump, you would just put jump. Get button down returns a boolean where if the button is pressed down, it is true, and if it's released, it is false. Wait, no. It only returns true the moment the button is pressed. So when you press the button down, it returns true for 1 frame. And then until you release the button and press it again, it will return false. There's also input.get button, which returns true when the button is being pushed and returns false when the button is released. And input.get button up, which only returns true the moment you release the button. So how would you use these? Well, you use if statements. If you're taking ICS 31, I think you've already gone over if statements. In C#, if statement, the syntax for if statements are slightly different. You need parentheses around the condition. So for this one, if you're using Python, you don't need the parentheses, but in C# you do. And also instead of colon, new line, and indenting, you use curly brackets. Yes.
Should there be a semicolon at the end?
Yes. I will fix that right now. Any other questions?
He's overturned bools, or he's overturned bools, or
Yes. The input.get button functions.
Oh,
Okay. So if you're trying to get the inputs, you would use if input.get button down, and then, or get button or whatever, and then whatever you put inside of the brackets is like what you want to do when the button is pressed. Since you have to check every frame, you put this in update, not start. So,
because you want to be running that if statement, checking for every frame.
yeah. So for example, in this one, if you have like a jump function and you want it to run when they press the jump button, you would do input.get button down and then jump. Because if you remember, there is an input called jump that Unity provides, which is space.
So we don't need like a function that returns a string, right?
Huh?
We don't need like any like thing that returns the string like, when you press the key.
No, this isn't Pygame. Pygame sucks.
That type of setup work is just here.
There's also axes, not axes, but axes. These basically represent like the controller joysticks. So, basically with these, it uses the directional keys and WASD, but like emulates a joystick. So with horizontal, you'll notice that it says a positive and a negative button in the information. What it means is that if you press right or D, it represents pushing the control stick to the right, while for the negative buttons, left and A, it represents pushing it in the opposite direction. So there's input.get axis, which takes it takes the name of the input as the parameter, as the argument, I meant, and it doesn't return a boolean like get button does, but instead it returns a number from 1 to -1 that represents the state of the control stick. So like 1 would be pushing it to the right, and -1 would be pushing it to the left, and not pushing it would be 0. Also, since it tries to emulate a control stick, but it's actually using like the directional pad, when you press right, it doesn't just immediately becomes 1. It'll like go from 0 to 1, like slightly.
Unity tries to smooth out the
Yeah.
So over the course of a few frames, it will go from 0 to 1 to roughly going up.
Yeah. If instead you want to you just want to know if it's being pressed, you use get axis raw, which
It doesn't do any of that smoothing.
Yeah.
As soon as you hit a button, you're in that state. You jump directly from -1 and back.
mhm. Yeah, there will be some games where you would want this. Any questions?
Does get access return a float?
A float, yeah. I think get axis raw also returns a float, even though it can only be 1, -1, and 0. Yes. It returns a float from -1 to 1 that represents where the control stick is. So like for horizontal, it's how far left and right the control stick is pushed. Yeah. Left and right are the names of the left and right directional buttons on your keyboard.
Unity's already mapped that for you because this way they have another like layer interpreting the controller input versus keyboard input. So these map everything from left over to right.
Yeah, you don't have to set this up yourself. Unity already did it for you. There's also a vertical one, not just a horizontal one, by the way.
Same idea.
For
just
up and down.
In the combination of the up and down axis and the left and right gives you eight directional as much as you want. within there.
Door.
Who's that fighting?
Hello. So, with axes, you probably shouldn't use if statements because they're not booleans. So instead of using if statements for that, you would use math because you're using numbers. So, since you know it ranges from 0 to 1, if you have like a speed, you can multiply it by whatever the function returns in order to control the movement. So like if it returns a positive number, you know that they're pressing right or up for vertical, so it would go to the right, and if it's a negative number, you know they're pressing left, so it would go to the left. And for control sticks, if they're like just slightly tilting it a bit, it'll return a number that's like between 1 and 0 but not like all the way, so it'll also be like slower than normal, so that's useful for this. If you're using get axis raw instead, then when you just press a button or when you move the control stick, it'll just immediately start moving. It won't like slowly start or stop. Yeah, so you can try this if you want. In update, you would, instead of using, just a number, you would use input.get axis, and normally you type horizontal, but you should probably use this instead, so that you won't, because it won't give you an error if you like type it wrong, because
It'll just silently fail.
or actually no, I think
Always between 0.
no, actually I think there will be an error because there's no like input for it, but like what I meant is there won't be compile errors. The only error when you run it. So if you run this, you'll be able to move it left and right. It'll be really fast because, you know, 1 unit's pretty big, but you won't be able to move up and down yet.
Are you using update or fixed update?
Update. Because we're not using physics right now.
What's the speed variable?
You just like define it whatever you want.
Oh, okay.
So like, if you have like float speed equals 0.5, and then you multiply it by that, it'll just essentially have how fast it's going. So now it's like more controllable. So now your challenge is to completely, or like finish the entire thing, to have it also move up and down using these functions, and also have it so that when you press the space button, the Unity logo also rotates. So you would use these functions, transform.translate, like how I showed you earlier, input.get axis for the translate, and for the rotation part you would use get button and transform.rotate. So you should start. And if you need help, I'm here.
So not fair. So not fair.
Unless you don't want to do it.
I do.
I have an issue. Like, is that like the switch doesn't actually work?
Mm,
That like it refuses to let me actually script to the object.
I mean, it should already be.
Well, I guess because when I try to add it, it so crap. Probably just because I reloaded it so much times. The dependencies probably got fucked up.
Probably.
I get it. Just to tell you so that way
Does anyone need help?
Is that it? Or
No, there's a lot more. We're still like,
ooh, that's a lot.
yeah, and
Dang.
oh, it's almost 140.
Pretty dope.
Okay, well, since I don't want to run out of time, though I could stay a bit after, this is the answer. I mean, you don't have to do it like this. You can have both of these in the same function, but for this example, it just uses it so you can like see it better. So
So I think it found
okay. So if you've done this, you'll notice something, that when you rotate it and then you move it, it starts moving weird. And the reason is because when you're using transform.translate, it's actually, oh wait, we're not there yet, but when you're using transform.translate, it's actually moving relative to the object's rotation. There are ways to, like, if you don't want that, there are ways to fix it, but we'll go over that later. For now, let's talk about frame rate independence. So, if you don't know what a frame is, how Unity works is there are usually 60 frames per second, but the frame is when like the screen refreshes. So every time something happens, it forms another image on your screen. That is a frame. So if your game runs at 60 frames per second, then every second there are 60 images that form, and that gives the illusion of a continuous action, I guess. But if your game lags, you'll notice that the FPS or frames per second might drop, and that might cause problems. So, say if your object moves 1 unit per frame, then if your game runs at 30 frames per second, it'll move 30 units. But if it's really fast and it runs at 300 frames per second, then it'll move 300 units per second instead. And sometimes you might not want that.
Quite often you don't want that.
Yeah. So instead, there's something called time.delta time. It returns a float, and it gives you the time that it took to render the last frame in seconds. Which means if you multiply time.delta time with whatever FPS you have, you'll get 1 second. And if you multiply it with velocity, you'll get distance, because distance equals velocity times time. So remember how earlier I multiplied input.get axis with a speed variable? If you also multiply that with time.delta time, the speed will tell you how many units the object will move per second instead of per frame. And that means that the speed will be frame rate independent, because if it's at 100 frames per second or 10 frames per second, it'll always move the same distance every second, which is what you should want. Any questions? Okay. So, if you have a speed of 5 and you translate it at the axis times the speed, and you multiply it by time.delta time, it'll start moving 5 units per second instead of 5 units per frame, which is actually really fast. And also you don't have to do it like we did earlier, where you just put the whole thing inside of translate. You can actually store them inside variables and then use those. It's a lot easier to read this way.
Basically.
And if you want to use this value somewhere else, it's easier to just use h_axis a lot rather than input.get axis horizontal everywhere. Any questions? If you want to, you can just try it out right now. So now, with the script that you have earlier, change it so that the sprite moves at 30 units per second, and it rotates 180 degrees per second using the other script. I will also do that along with you. So
So when you use speed, you're just thinking of, that's a constant, right, that you set.
yeah.
Is there a way to get the current frames per second?
1 divided by time.delta time.
Oh, okay. That's great.
help.
Actually, I can run on this one. It's red.
It's definitely making me take like 5 games. Is that it?
No, there's more. I feel like I missed the slide. Yeah, I definitely did. Where is it? Oh, yes, I missed this one. Somehow.
Is this the oh?
Yeah.
Oh, that's cool.
Yeah.
Wait. X, Y, Z.
Yeah.
Wait, so like, when we use translate originally, we had to use arguments. So like so does translate actually just take 4 arguments, but like there's like a keyword, like a default value?
No. Okay, there are like 4 different versions of translate.
With the same names?
Yeah, it's called function overloading.
Oh.
As long as it's not like ambiguous of, cause like if someone types in transform.translate and puts in like certain arguments, as long as it's not ambiguous which one it's referring to, it should be fine.
Okay.
So like there's one that takes one parameter, a vector parameter, one that takes a vector and a space, one that takes an XYZ, and one that takes XYZ and space. So there's 4 versions of it. Anyway, so I missed this slide, so you should probably just look. If you notice that if you were rotating it and then using translate at the same time, the object moved relative to its rotation. So if you like press up, but it's rotated like 90 degrees, it'll move left instead. Sometimes you would want this if you have like tank controls, but often you don't. So you can actually add a 4th argument, space.world, that makes it so that it moves relative to the world rather than the object itself, and this way it won't move weird.
So can you set it to another object inside the world?
No, it's only space.world and space.self. I don't know why you would use space.self, because if you omit space.world, it's basically space.self. Okay, back to the other thing. Oh yeah, I should probably add that as well.
Interesting stuff. Yeah, I think that might work.
Oh no, 8 minutes left.
Can try it with can try it with the one.
Okay. And basically this is the answer. Or you can like compact it into 3 lines if you really wanted to.
Dude, I know about this. It's 32. I didn't use my technical problems.
Any questions? Okay.
I figured out another way. I don't know no, you can't get okay. You set the clock. We're going to use the clock.
Next, we'll talk about vectors. There are 4 different kinds of vectors in Unity, but for now we'll just be talking about vector 3s. sometimes you would want to like just directly set the position or rotation or scale. So like instead of saying move it this amount, you want just set it to this position. Or sometimes you want to get the position instead and check its X or Y value. So to do that, you would use these. There's transform.position, which gives you a vector 3 containing the XYZ position of the position. There's transform.Euler angles, which gives you the rotation in XYZ. And there's transform.local scale, which gives you the scale. This is one of the only ways to actually modify scale in the code because there's no like change scale method. Or
So
yeah. There's also a transform.rotation, but that returns a quaternion, and that's really hard to explain. It's basically like complex numbers in a 4D space, and it's really hard to visualize. The reason why Unity and a lot of other programs use it is because it's actually easy to like for computers to like calculate rotations using quaternions compared to using Euler angles. But since most of us can only think in like XYZ, we'll be using Euler angles instead of rotation. So you do transform.position equals a new position in order to set the values of it. But like, how do you set a vector 3? Well, a vector 3 is basically like an object that stores an XYZ position. It also has functions that lets you like easily calculate like magnitude or square magnitude or like compare distances or add them together. So in order to create a new vector 3, you just do new vector 3 and then in parentheses the XYZ components separated by commas. You can also store them in a variable if you want to. In fact, it's probably easier to read that way. And most of the functions that take an XYZ argument should also take a vector. So like you can do transform.translate and then a vector instead of like XYZ. But you probably would only do this if you have a vector already.
does the F need to be explicit or not?
Yes, because Unity uses floats. If you don't have an F, it's a double instead.
Okay.
So it's if you have like an X and a Y and a Z amount that you want to move, it's probably better to do transform.translate XYZ instead of just creating a new vector just to use translate with it. Same for rotation. Rotation can take a vector. And with vectors, you can also like modify it with like adding them together or subtracting or multiplying and dividing it by a scalar. So if you add or subtract vectors, it basically adds the XYZ components together individually. And for multiplication and division, it multiplies or divides each of the components by that value. So for example, with transform.position, you can like change the position like that with transform.position equals new vector 0, 1.5, 0, which basically sets, like running this just sets the position to that coordinate instead of just moving it. You can also move the object with by using plus equals. Plus equals is basically equals and then the value added to the original value.
So if you take like 1, 0, 0 and you have 1, 0, 0, you get 2, 0, 0.
Yeah. You can also modify transform the Euler angles and local scale like this. And this is like I said, the only way to change scale. Because, yeah. So now we're gonna take what we had earlier and just change it so that it's using plus equals a vector instead of using translate and rotate. But you probably shouldn't use transform the Euler angles with plus equals because it might cause gimbal locking, or like the Unity documentation says that it might not work when the angle exceeds 360. You probably wouldn't even need to use transform.Euler angles plus equals simply because transform.rotate exists.
So like when you create new vector objects, right, would it be like good practice to delete them?
Delete them?
Because like
Vectors aren't really that big of a memory. They're free floats. The garbage collector can handle this normally, though it is good in general to whenever you can find one to delete it. Unfortunately, C# is not a what's it called? We can't manage our memory in it. Like things fall out of scope.
Oh, okay.
But those are kind of throwaway objects. It's pretty cheap to just make them and forget about them. So you don't feel too bad about having them anywhere.
So garbage collection is somewhat automatic.
It is automatic. In fact, every few seconds you will notice you stutter. Usually that's because of collection, evaluating your project, getting rid of things that no longer need to exist.
Okay.
So instead of using transform.translate, you would do transform.position plus equals new vector 3. Also, there are vector 2 and vector 4, but
Which are 2 floats and 4 floats.
yeah.
What would the fourth float be in vector 4?
Literally nothing. I mean, a vector is not actually meaning on its own. A vector is just a collection of floats. It's how you use it that matters. Usually vector 4s are for, I've seen them used for colors, where the first 3 represent blue channels and the 4th is alpha value. I've seen something similar used in a shader's properties, which is called the pass frequently.
Okay.
I know certain types of transformations, 4x4 matrices, represent information on something. Yeah, it depends how you apply it.
So there
Did
isn't like
something wrong.
is it like a vector but like basically like in place of like a tuple?
The reason why they have 2, 3, and 4 is because in C# tuples don't exist, so they say, alright, well here's the one if you want to. It's hard coded.
That's interesting.
Yeah. So this is basically the answer. You just take transform.position plus equals displacement x and displacement y, which is input.getAxis times speed times time. Oh yeah, also there is a constructor of vector 3 that only takes two arguments. It will automatically set the z to 0 if you don't have it. Any questions?
Wait, just to clarify, just 2 arguments, like, or like you just put 3 in the same time.
You can just put 2 arguments in a vector 3 constructor. It will automatically set z to 0. And that is it. Yes, I am 2 minutes late. But yeah, that is the end of this workshop. So many people just left. But next week we'll talk about prefabs and physics, and that's going to be a lot. And if you need to look at the documentation, here it is. I highly recommend you look at it, because transform has a lot more than the functions and variables that I mentioned.
Do you have all the slides that you just went over?
Yeah, I'll post it on the Discord after. Hopefully this is enough to help you on the game jam tomorrow.
Well, assuming I can go, I think I need a fish 51.
Okay.